So obviously wind energy is very successful at this moment already. And it is actually technology that we want to push forward to do the green energy transition and to really replace coal-fired and oil-fired plants. However, there's still a lot of interesting opportunities. We can make this a technology that is, in the coming 20, 30 years, going to be a lot cheaper still if we manage to handle the complex interaction between the wind farm and the wind system. Nowadays, we manage to do that, but we are still grasping at understanding the complexity of the physics, and somehow we manage to do that still at this point. But there is a lot of opportunity that we are not using yet in this complex wind system, and that is also where the wind farm control story comes in. So I think one very important aspect, and I mentioned that already, is obviously that if you have an efficient wind farm control, you could potentially, in a denser wind farm, alleviate some of the energy losses that you expect, alleviate some of the load losses, the load increases that you expect in downstream turbines, and so you may be able to densify wind farms. That's one, at least, prospect that we see. But there's much more to wind energy than just only getting as much energy as possible out of the air, because in essence the wind farm is part of a bigger electricity system, and so in that bigger electricity system, very often you need just a lot of energy, and you're happy to give that, and that's one possible objective. But other times you may just want to balance or help the system to balance itself, and so you may need to respond to demands from, let's say, the electricity infrastructure, the power grid. And also being agile and being versatile in the way you respond to this kind of demands is one aspect of wind farm control that will become very important in the future.